Hi guys, this is the Innovative Minds tutor. So in this video we are going to work with calculus grade 12. So specifically we are going to work with the first principle. Right, we use this formula to define the derivative. Actually it defines the derivative, right? So when we are working with when you want to find a derivative from first principle, you will be required to use this formula, which is the derivative of f of x, which is equals to limit as h approaches 0. So always remember this part, it's always going to be the given function. So in this case, the given function is x squared plus 1, right? So the question states that determine the derivative of f of x squared plus 1 from first principles. Actually, in later stages we will learn more about how to in easiest way without using the first principle, but in this case we'll focus on the first principle. If you are new to this video, if you're new to this channel, or kindly subscribe. You only subscribe once. So let's start today's video. Right, first thing first, you will write the formula, which is the derivative of f of x, which is equals to f at x plus h minus the given function divided by h. No? So after that, where there is x, you replace it by x plus h squared. Remember, where there is x squared, we are going to replace it by x plus h minus the given function, which is x squared, which is this one, plus 1, right? Then we will then divide by h. Okay, don't forget limit as h approaches 0. Don't forget limit as h approaches 0. Okay, so limit as h approaches 0. So let's, after that, we are going to work out the brackets, So we'll square the first, we'll square x here. So this 2 multiplies everything that is inside the bracket. So when you say x, 2 multiplied by x is 2x plus h, that will be 2xh. Then you will square the last, then that will be h squared. Then this negative multiply everything that is inside the bracket. So we are going to have negative x squared minus 1, then divided by h. So from there, we will have to calculate, we will have to have like terms. You can see, guys, from there, the like terms is x squared and x squared, which will give you 0. So we'll cancel this. So what are we left with? We're left with 2xh plus h squared minus 1 divided, okay. Oh, I made a mistake somewhere here. I could see that this was x squared plus 1. So it was supposed to be plus 1 here as well. Sorry for that. Right, let's put that plus 1 here, because let's place that plus 1 here. Okay, when you place that plus 1 here, that means this is out. So actually we are left with 2xh plus h squared. Then you will have to take out the highest common factor. So that will be 2x here. To get to h squared, we will need h. Then we will factor out, right? H and h, they will go. Remember that this is limit as h approaches 0. Limit as h approaches 0. So what are we left with? We are left with limit as h approaches 0, which is 2x plus h. So when we replace h with 0, we'll be left with 2x plus 0, which is 2x. So our solution will be 2x. So the derivative of x squared plus 1 will be 2x. Will be 2x. So that's how it should be. Now let's go to the second question. Now at the second question, guys, yes, there was a mistake. I hope you saw, guys. That's why I was able to cancel this, because this positive 1 and minus 1, they will definitely kill each other. They will cancel each other. So definitely our answer is 2x there. So make sure you follow the steps very well. Let's go to our last question. So Now, our last question, guys, here. Let's take a look at this. You're given a fraction, right? When you're given a fraction like this, as always, we have to write the formula, which is x plus h minus the given function, right, divided by h. So meaning, guys, that where we see x, you replace by x plus h minus the given function, which is 2 all over x. Do not forget to put limit as h approaches 0, limit as h approaches 0 divided by h. Okay, so let's work it out. Let's work it out without rushing. So we can see here, since it's a fraction, you find an LCD. The LCD here will be x multiplied by x plus h. That will be our LCD here, right? So we will place our LCD here, x multiplied by x plus h. Then I can use a cross method. Can cross multiply here since it's a fraction. 2 times x, that will be 2x, and this will be 2 plus h, and multiply it, right? Divided by, we have this h divided by h. Okay, so let me multiply out. We are left with 2x here. This negative 2, this 2, negative 2, multiply everything that is inside the bracket. Negative 2 multiplied by x, that will be negative 2x, and negative 2 times h, that will be negative 2h, right? Then here x times x, that will be x squared, x times h, that will be xh. Then the like terms we can see, remember that we divide by h here. The like terms, 2x and 2x, they will cancel each other. We will be left with negative 2h. So let's contend this. We have negative 2h. We also have x squared there plus xh. Remember, this is h divided by 1. So we'll find the reciprocal. The reciprocal of this will be 1 all over h, right? So yes, it will be 1 over h, the reciprocal or the inverse of this. So we can see that this h and h, they will cancel each other. What are we left with? We are left with negative 2 multiplied by 1, which is negative 2. So you have x squared plus xh. Guys, do not forget to put limit as h approaches 0. Limit as h approaches okay, let me just put limit as h approaches 0. So we'll go with that, limit as h approaches 0. Okay, as well here we'll have limit as h approaches 0. Okay, now what you could see, where there is h, you're going to put 0 then. So 0 times x is 0, 0 plus x squared, that will be x squared. So we are left with negative 2 all over x squared. So the derivative of this will be negative 2 all over x squared. So that's how it should be, guys, right? Hope you find this video useful. Know how to simplify your brackets, know how to substitute, always check. And yeah, those are the steps that you need to follow, guys, when working with first principle. See you on our part 2 video, where we'll work with a function that is a cube. But now we're focusing on the one that it's a quadratic, as well as the one that has a fraction, right? Hope you find this video useful. Actually, this is a hyperbola. Yes, we're deriving the hyperbola as well as the quadratic function. Okay, see you in the next video. Take care, and do not forget to subscribe. You only subscribe once. Thank you.